Good morning, everybody. So we're going to be looking at number 44 next. First, we identify what type of equation this is. Because this has ln, this is a logarithmic equation. There is one log, so to solve it, we need to put this log into exponential form. So this is when it's important that you know what natural log actually stands for, which is log base e of 4x equals 3. So I like to rewrite it by replacing that natural log with log base e first and then writing it in exponential form. So we see the word log and we think of the elephant with his big animal ears. So our base is e, our exponent is 3, and our answer is 4x. So folks, you don't have to show this step of work, but I do strongly recommend it because that just emphasizes that natural log is really log base e. So now this is an exponential form, but it's not an exponential equation because my variable is at ground level. So in order to isolate this x, all we would need to do is divide both sides by 4. So x equals e to the third over 4. So this is going to be one of those nasty decimals that we get on our calculator. So second natural log, we get e to the third, arrow over to go to ground level, and then divided by 4, and we get 5.021, rounding to the thousandths place. So that's kind of come into play on our test and also on my math lab. Thousandths place is 3 places past the decimal. So x is equal to 5.021. But before we put a box around this one, since this is a logarithmic equation, we do have to check for extraneous solutions. So looking at the answer part of my log, we've got 4x. So 4 times 5.021 is definitely going to be greater than 0. So that truly is our solution. So again, folks, it's really important on any problem with a log that you always verify that the solution makes your answer part greater than 0. So let's go ahead and take a look at number 45 next. And actually, why don't you go ahead and pause the video and try this one on your own. So again, we've got a single log equation, so we're going to want to put this in exponential form to solve. So log base e of negative 2x equals 7. So big animal ears. Our base is e. Our exponent is 7, and our answer is negative 2x. And again, it's in exponential form, but our variable is at ground level, so to solve for it, we're going to go ahead and divide by negative 2. And again, typing that in on our calculator, we get second natural log to get that base e to the 7th, and then divided by negative 2. And ew, we get negative 548.317. Oh. But before we put a box around this absolutely horrible decimal, we do still need to check to see if it's extraneous. So looking at the answer part of our log, if I have a negative 2 times this big nasty negative 548.317, we do end up getting something positive or something that's greater than 0. So notice I'm not even figuring out what it's equal to on my calculator. I just know it will be greater than 0. So that's enough to prove that that would not be an extraneous solution. All right, folks, moving on to the next one. We've got natural log of x plus 2 equals 3. Now, this is a logarithmic equation, just like the last one, so we're going to have to put it in exponential form to solve. But the issue that some students have here is they say, well, is this log isolated? Folks, can I steal a negative 2 from underneath? Or from inside those parentheses? No, for the same reason you can't steal stuff from underneath a radical or underneath a square root. That plus 2 is trapped on the inside, so that's as isolated as our log will be. So we go ahead and go directly to replacing natural log with log base e. And then big animal ears. So again, for those single log equations, you write it in exponential form. So our base is e. Our exponent is 3. Our answer is x plus 2. So again, it's in exponential form, but it's not an exponential equation because our variable is at ground level. So to solve for it, we will simply subtract 2. And that ends up giving us 18.086. But before we put a box around it, we have to check to make sure it's not extraneous. So plugging it into the answer part of our log, we get 18.086 plus 2. That's definitely going to be greater than 0. So that truly is our solution. All right, moving on to the last problem on this page. We've got 3 times the natural log of x equals 5. So again, I have a single log, so we're going to have to put it in exponential form to solve. But before I do that, we do need to isolate the log on this one. So I would put a star by this problem and just circle that 3, because before we put it in exponential form, we have to divide that by 3. So natural log of x equals 5 thirds. Now, if you wanted to, you could also have moved that coefficient back up as a power of the x. So there's actually 2 ways you can handle that coefficient of 3, but I do think this way is a little bit easier. So natural log of x equals 5 thirds. Natural log is the same as log base e of x equals 5 thirds. And then big animal ears. Our base is e. Our exponent is 5 thirds. And our answer part is x. So it looks pretty gross, but we can type this in on our calculator. And folks using the older calculators, please, please, please make sure that you enclose that 5 thirds in parentheses. Otherwise, your calculator will take e to the 5th and then just divide that whole thing by 3 at ground level. So newer calculators, you can just do e to the 5 divided by 3. Older calculators have those parentheses. And we get 5.294. And checking for extraneous solutions. That makes the answer part of our log greater than 0. So that's our solution. And again, I won't be picky about those squiggle equal signs, but it's not a bad idea to have them. I'm going to go ahead and show you the second way of solving this one. So I'm going to go ahead and make use of this space up here. So as I mentioned, you could also have moved that 3 back up as a power of the x first, which would give us natural log of x cubed equals 5. So then log base e of x cubed equals 5. So big animal ears. Our base is e. Our exponent is 5. And our answer is x to the 3rd. Now, folks, from here, and this is why the way I showed you initially is a little bit easier, in order to isolate our x here, we would have to take the cube root of both sides. So just like square root gets rid of x squared, cube root gets rid of x cubed. But as you've probably noticed, there isn't a cube root on our calculator, so we're actually going to use that exponent knowledge that we talked about earlier in this chapter. Taking the cube root of something is the same as taking it to the 1/3 power. So if I 1/3 power both sides, 3 times 1/3 gives me x to the 1st, or just x. And using math spam, I'm powering up, so I would multiply those exponents and voila. That gets me e to the 5/3, just like we had down below. So this just verifies that, yeah, that weird little funky power rule that says you can make coefficients back up as exponents of log answer parts. That proves that this is true, and it's also a second way of solving this problem. So folks, after doing these few pages of solving powerlifting, I hope that you feel better about how to know when to do what on these problems. So on the next page, we have the solving showdown. This has all of the different types of equations all scrambled up. So I recommend that you take a deep breath and you try solving this maybe without looking back at your homework packet first. See how much you remember from the videos that you have already watched. Couple of things. Make sure you check for extraneous solutions where applicable. And also, round to the thousands place. So there are 11 questions on here. Folks, this is going to be a really good indicator if you are ready for that upcoming test. So do these problems carefully. Make sure you are marking your wrong answers wrong. And again, folks, as long as you're just putting slashes through the ones that you miss, you don't have to go through and make corrections. That feedback is for you, so you know if you're doing them correctly. That feedback is for me, so that if when you turn it in, I can give you feedback on those problems via email. But this will be a good indicator of whether you are ready for the test. So though you don't have to make corrections, it's not a bad idea to do so to prepare yourself on this particular assignment. Also, don't forget that you also will need to go back and do the remainder of page 10. This is also like that solving showdown where we've got a mixture of different types of solving problems on both page 10 and page 11. And we've got this happy little story problem here for you to do as well. So folks, that concludes our videos over Unit 6. Please keep emailing me all the wonderful questions that you have, and I will see you in our next chapter where we talk about limits.